Good afternoon. What you're going to be listening to this afternoon is a little bit different than what we've been presenting in the past. We really want to start showing people the how the money is going to be saved versus rather than just speaking to it. So that's why the title, Save Money with Clean and Liquid Fuels. Part of the NYC plan, this is Local Law 43, main focus is on the air quality of the city encompassing all boroughs. Public health and air quality. Main focus, of course, is the elimination of the 6 and 4 heavy fuel oils, which cause the greatest impact to the emissions being put into the air through the use of boiler operation, obviously. What we're seeing with the New York City community from 2008 through 2013 is the diagram within the two diagrams. The first diagram on the left is the initial survey that was done, as you can see, in 2008 and 2009, where you could see the density of the pollution that encompasses the boroughs. It was redone in 2012, 2013, and you could visually see the differences that have been created over the years and the positive effects with the Clean Heat program. Still focusing on the Upper East Side, West Side, and Midtown Manhattan and Upper Manhattan as the most dense areas of the pollution. You can see nickel emissions have declined by 35%, as well as the PM 2.5 levels. So we're on the right track. Again, the main focus is to eliminate the pollution, which is a health situation, which you can see is a cause of deaths, emergency room asthma visits, and hospitalizations. Just to go back to the regulation a little bit, a lot of people have heard this before, and it's very important for everybody to know. As of July 1st of 2012, the DEP no longer approved certificates of operation for number 6. As buildings received permits to continue operation prior to that date, they have until 2015 to do something. What we're going to be talking about today is let's not wait until 2015 and the reasons why. Phase 2 of the program, where those buildings that were burning 4 or converted to 4 have until 2030, or very importantly, when their boiler burner needs to be replaced, they're going to have to go to 2. So if you're burning 4, you're going to have to realize that if your burner needs to be replaced, you're going to be told to go to 2. If you converted to 6 and you went to 4, that if in a year or 2 or whenever your burner needs to be replaced, you're going to have to do it again. Clean Heat program is a fuel neutral program. Our mission, again, I'm going to say this numerous times, is to clean the air, and we're doing that with the elimination of number 6 and number 4 heavy fuel oils. Your options are to go to any of the cleaner fuel oils. You can go to ultra low sulfur 2, you can go to biodiesel blends, you can go to natural gas, steam, or if geothermal is something that you're looking at, that's great. Also solar or cogeneration, anything that reduces the amount of emissions that are being emitted into the air. Just a little questionnaires coming up. If you would be, let us know what grade oil does your building use. If you don't mind, you can just plug in some numbers for me, and this gives me an idea of the audience I'm speaking with. If you are a trade, obviously just click trade, and if you really don't know, just put you don't know. So we'll just wait a few minutes and a couple of seconds, and we'll get some numbers going here. So, all right. So let's see. Not too many have put information in, but there's a lot of trades on the line. So this is actually very good because the trades that are going to be speaking to the population. It's very important that this information gets out there because the webinar can only speak to so many, but the trades, you're speaking to many more. So it's very important. Clean Heat, that's the team that we're working with the city. We offer the technical assistance. That technical assistance comes in many ways. It comes through a website that we have that will offer much information. Staff that'll do what we're doing right now, and that's basically education, giving information to those buildings that need to understand what the program is, what the regulation is, when to do it, why to do it, and to what fuel. So we're really here. We're working closely with the utilities. We're working closely with the industry leaders. And we are here to do whatever it takes to get the buildings to understand what they need to do. So here we go. Why liquid fuels? Switching to cleaner burning heating oils from heavy oils has a number of big advantages for your buildings. One is the heavy oils create inefficiencies in your heating system. This is important when people are looking at their grade of oil and they focus on the few cents per gallon. I believe we're going to talk about that, but I'm just going to give a little prefix here that currently if you look at the market, the cost of the grades of fuel are converging. Where in the past number 2 was a little bit more expensive or way more expensive way back, they're pretty much in line with each other now. So 6 or 4 or 2, if you look at it, there's only pennies different. If you look at the wholesale market, number 2 is up to 20 cents cheaper than 4 and 6. So it's important to understand the market when making these decisions. Getting in compliance. As I indicated just before, if you go to 4, you may have to go to 2 in a year or 2 when your burner's replaced. Why do something twice? What we're looking at for those buildings that are in the process of converting to gas, that's great. But why hold on to your heavy fuels while you're doing that conversion? You're most likely going to have to be replacing your burner. Make that a phase 1 of your project. Get started in saving on your fuels, and then when the gas is completed, then you can switch and fire up on your burners on the gas part. Take advantage of the biodiesel now. Through the New York State rebate, a building is allowed up to 20 cents per gallon, and it's set this way. A B20 is, say, 20%, B2 is 2%, and so forth. You're allowed a penny per percent per gallon rebate at the end of the year. So at the end of the year, you call up your oil company, you get your total gallons used that year, and you submit the proper paperwork. We have that on our website as well, and I believe it's in this presentation. We'll get to that later. But you could see up to 20 cents cheaper per gallon. Now, the use of biofuel is also very good. It aids in a more cleaner burning system. So again, I'm going to get to that a little bit later. Main goal, reduce the greenhouse gas and the PM 2.5 emissions your building is responsible for now. So, this is where we start to get a little fun. I'm going to throw my engineering hat on. I have fun with this when I'm talking to people because just people may not understand this. And maybe some people do, so that's okay. So I'm going to go over it anyway. Your boiler, this is very simplistic. There's a fire side and the water side of your boiler. You see your burner, you see your oil tank, you see your side-on heater and your preheater. Now, that diagram up there, a clean tube sheet, that's your heat exchange element there within your boiler. So your flame heat one side, the hot gases go through those tubes and it heats the medium, which is the water, that is on the other side of those tubes to a specific temperature that's controlled by your thermostat. So the tube sheet separates the heat from the water that is made into steam for heat and domestic hot water. This is where the heat transfer occurs. So this is going to be the gist of the whole presentation right here, what's happening at that tube sheet. So the U.S. Department of Energy, I'm not making this stuff up, so the U.S. Department of Energy indicates that a clean heat transfer surface can improve system efficiency. These contaminants impede the efficient transfer of heat and reduce the efficiency of heating systems. What does that mean? Clean surface of the tube sheet provides maximum heat transfer. As soot is built up on the tube sheet, heat transfer is diminished, resulting in loss of efficiency. As little as 1/8 of an inch of soot can reduce efficiency levels by 8.5%. Now, that's a clean tube sheet on the top, and that's a dirty tube sheet on the bottom. Now, obviously, it doesn't all lay flat on your sheet, but it also penetrates into your tube. So when you have a cleaning done by your maintenance contractor, if he's not getting all the way into those tubes, which actually exit the other side of the boiler, you still have an insulating layer. Now what happens with the soot is it creates an insulation barrier. So as this barrier increases in thickness, it takes more fuel to do the same amount of work. I'll explain. But first I want to talk about what you're burning in your boiler. Now I saw some people that were burning number 6, but again, there are a lot more trades that are in this presentation, which is great. But in number 6, the product is very thick in its natural state, and it must be maintained at approximately 100 degrees Fahrenheit in the tank in order to flow. In addition, a sidearm heater and a preheater are required prior to the fuel being injected into the boiler. High levels of maintenance are required, and the preheater is an electrical component. I'm going to focus on that later, so please keep that in mind. Number 4, product is not as viscous as number 6, and it's comprised of a blend of 47% 6 and 53% 2. Preheater is still required. Maintenance is still an issue, and the preheater is an electrical component. Now we talk about ULS2. It's the same grade of fuel as the automotive application. The only difference is its color. But the parts per million through the new refinement has brought it down to 15 parts per million from 15 parts per million, making this a very, very clean fuel. There's no preheating required, and the maintenance is very low because of the cleanliness of the fuel. And then, good thing about this, increased purchase potential to secure the best price for your building. So now we're going to break down the boiler in this operation. This is a layout that you've seen earlier of a number 6 fired boiler. The fuel is delivered into the tank, from the tank to the burner, and it needs to be preheated to allow the fuel to flow in addition to the required sidearm heater. Now, when you burn a number 6, some of the energy that's being used per gallon is transferred to the tank and then through the sidearm heater. That's where the energy to keep the tank at 100 degrees comes from. So next, the flame created by the burner burns fuel. Soot deposits are created on the tube sheet. Now this happens over time, and as more time passes, there's more soot that builds up. So it's not a linear progression. Well, actually, it could be a linear progression of inefficient operation. The increase in soot buildup results in elevated flue gas temperatures and loss in efficiency. Your super of the building may say, oh, okay, he may use this as a gauge, that the temperature has risen this amount of degrees, so therefore now I know I need to clean my boiler. And that's the indication as to when that happens. So that's a key indicator to the building as to when they need to do that. With number 6, it's going to happen often and more quickly than the other fuels. Now, the remaining energy from the fuel goes to heating and hot water for your building. So in this scenario, we're going to move on. So in this scenario, basically what happened is as the soot built up, it required more fuel to do the same amount of work. And that's what we're talking about here. What are you really paying for? Soot buildup on the tube sheet occurs quickly due to high viscosity and density levels of the metals inherent in number 6. The buildup decreases operation efficiency as deposits thicken. The result, normal operation requires more fuel to heat the living space within the building. In addition, electricity and fuel are used to keep the number 6 at 100 degrees. Now, here we get to some numbers. I took an example of a building at 73,000 gallons of number 6 fuel oil. We have a calculator that we use to talk to building representatives if they need to understand the comparisons. And I kept the pricing at 10 cents per grade difference. So in this scenario, we're looking at number 6 to be at $2.90. Now again, these are all just comparisons. These are not engineering studies, but the results of the study indicated that under soot-free conditions, this same building should have only burned about 63,000 gallons. That's 10,000 gallons additional fuel that was used to bypass the soot buildup and heat the tank, which could be minimal, but the most efficient loss is in the soot buildup. DOE indicates that I say 1/8 of an inch is 8.5. 1/4 of an inch, if you put your fingers together and figure out what 1/4 of an inch is, that's 16% inefficient operation. So basically, you've lost $29,000 in fuel. your electric preheater at approximately $10,000 per year. And those are the assumptions I use, which I've run by many people, and they're sound assumptions. Let's talk about number 4. In this particular case with number 4, you don't need to maintain temperature in your tank, and your side-on heater is removed. So that's good. You still have a preheater, which is that $10,000 number that I just showed you earlier. Similarly, the flame created by the burner creates the deposits on the tube sheet. Not as quickly as 6, but they're still there because of that 47% number 6 volume in the fuel oil per gallon. Again, increase in soot buildup results in elevated flue gas temperatures and loss in efficiency. If you could visualize a flame that's heating, that's aimed at the tube sheet, but some of that flame can't get through to the water through heat transfer, that flame is going up your stack. So that's how the losses are actually could be visualized. Energy from fuel goes to heating your hot water to your building, and steam and hot water to your building. So again, we want to see all that energy doing good heat transfer work to get to the water. What actually happens in that case, once the temperature is satisfied with, say, the thermostat simplifying it all, then it stops operation, it stops burning. So you have less fuel that's being used to do the same amount of work. Again here, similar slide, but what are you really paying for? Number 4 is a blend of 6 and 2. The density levels of the metals found in 6 are reduced, but still exist. That's still almost 50%. Therefore, the soot buildup on the tube sheet occurs, but not as quickly. And this buildup leads to gradual decrease in efficiency as deposits thicken. More fuel is required to heat the living space. In addition to fuel having a lower heating value, that's the BTU that people talk about. Oh, this fuel has a lower BTU value. Yeah, that's true, but it's not a large percentage. Numbers that I work with say number 6 is 150,000, number 4 is about 145. Again, I'm simplifying this, and number 2 is about 138. So we'll talk. So in the example, a building burning 73,000 gallons, conversion to number 4 from 6, actually, since you have the same amount of soot buildup, maybe just a little bit less, again, this is just a comparison. Now you're looking at 77,000 gallons in usage, and that's because now you do the conversion from the 150 to the 145,000 BTUs. You actually now, to do the same amount of work, are using an additional 4,000 gallons. In this example, I'm using 10-cent difference. So now you're at $3 a gallon, you're burning and using, in addition, a $12,000 difference than what you should be doing if your system is burning clean. You still have that electric preheater at 10,000 gallons. So, and these are my assumptions, 6,500 hours and 20 cents a kW. So you're using a little bit more, you're paying a little bit more. The perception is that you're saving money. So hopefully as we go through this, you'll have questions. So now your boiler operation on number 2. Both the preheater and the side-on heater are removed. You don't have to keep the tank warm because the fuel oil, like I said, it's automotive grade. It's liquid. No viscosity at all. So you have, again, fuel is delivered to burner from tank. And then the flame created by the burner burns fuel. Soot deposits are minimized. I'm not saying it's not going to happen, but I'm saying that they're minimized due to the clean operation of the system. I talked about 1/4 of an inch, I talked about 1/8 of an inch. I calculate about 1/32 of an inch, again, using DOE standards for soot buildup when utilizing number 2. And these were also verified through some tests that I had done with real buildings in the city, just to get a sample of what we're talking about is actual. Decrease in soot buildup results in maintained flue gas temperatures and maximized heat transfer. What we're saying here is that you can go longer between cleanings when you're burning clean. And people do say that. I'm burning 2. I only clean my boiler once a year. That's great. Some people say that they're cleaning the boiler if they're burning heavy fuels 2 or 3 times a year. What I'm saying is, why spend the money on maintenance? Clean it once and burn clean and save money. Energy from fuel goes to heating and hot water for your building. So saving money but using an efficient fuel. Here are the characteristics due to the cleanliness of the ULS2, and that's really number 2, but now since it's been refined, it's now called ultra low sulfur number 2. The reduced levels of the metals inherent in the heavy fuels are gone. You do have some soot buildup because it is a fossil fuel, but not at the rate that you would be with 6 and 4. What's the result? The lack of soot buildup allows for normal operation, and it requires less fuel to heat the living space, regardless of the lower BTU value. And what's also nice, and I heard this from the building that just recently converted, is that they don't have that strong odor during the delivery. It's a strong odor. You're still going to have an odor, but it's not as if you were getting a delivery of 6 or 4. In my example here, still looking at the same 73,000 gallons through my calculations. Due to efficient operation, the lack of soot buildup or the reduced amount of soot buildup, the conversion only is the gallons in usage is only at 71,000 gallons. Again, using a 10-cent increase in price, the building is actually saving $6,000. There's no electric preheating required. There's savings on that end of about $10,000. And so these are the benefits of going number 2. We have case studies. We have a case study in our website that talks about a building that burns 27,000 gallons. Small building, but it's a good reference for the population of the buildings in the city. And they tout the savings that they've seen, and they're actually using less. Here's the Biodiesel Tax Incentive picture that talks about the form that will be required to get that penny per gallon for each percent of biodiesel up to 20 cents. So we're here to explain it further after this presentation, and we'd love to talk about it. We'd love to see this. I once saw a slide at a meeting, at a conference, that the biodiesel has a little bit of oxygen in it. There's a little oxygen molecule down at the end of the chain, and it actually enhances the flame, which helps helps with a more clean burn. So I always thought that was pretty cool. It stuck in my mind. So hopefully it'll stay in yours. ULS2 with biodiesel. We're looking at moving buildings from 6 and 4 to natural gas in number 2. But you can see from this chart here that going with the number 2 ULS, ultra low sulfur 2, reduces the particulate matter over 99%. It's actually, when we look at PM 2.5, it's actually cleaner than natural gas. Obviously, natural gas is the lower greenhouse gases, but we're looking at the metals and the sulfurs that are being emitted into the air. So going to number 2 is a really good thing for the city and for everybody who lives in the city. If you live in the city, you are breathing the air that these buildings are emitting everything into. Still not convinced? That's the Empire State Building. Visually speaking, 1 pound of PM 2.5 can saturate a volume of air larger than the Empire State Building. Now, on average, we're looking at buildings that are in the 40,000 square foot range. Each one of them emits, at a minimum, 222 pounds. So hopefully looking at that and thinking about what we just talked about will kind of show you the benefits of why you need to burn clean and not waiting until your triennial expiration expires, but to do it now. As I said, if you're in the midst of doing a conversion, that's great. To gas, that's great, but don't wait and look at your project in 2 phases. Get rid of your burner, put a new burner in, clean your tank, test it, make sure you test your tank, and then put number 2 in there. And then, when you've converted, then you're ready to go.